morning, everyone. Welcome to our talk on Quirks of scaling of custom controllers. I'm Amit, and I have Ashutosh with me. We work for a company called MyData, which is behind the project openebs. It has got recently into the CNCF as a sandbox project. It deals with block storage. We'll come back to it, more about it. So let's get started. All right. So what we do basically is manage storage in Kubernetes. So most of us must have heard of Kubernetes being used as an API to build distributed systems or distributed applications. What openebs does is it uses Kubernetes as an API to provide block storage. So in essence, it tries to solve the storage problems of Kubernetes using Kubernetes as an API. Okay, all right. So if anyone is familiar with Kubernetes and the custom controllers, so this is an idiomatic way, an idiomatic approach to build applications in Kubernetes, right? So it's a way to extend the Kubernetes by writing your custom controllers or effectively known as custom resources, which is act as a spec or an intent to the end users, right? So even for this particular case, what we do is we define the custom resources, and in this particular example that I've taken is known as a storage pool claim. It's basically one can imagine a set of disks, right? You aggregate all those disks and you give a storage out of it. And we basically deal with block storage. So this is about the block storage part. And yeah, so when we are dealing with Kubernetes controllers, it essentially means reconciliation between the desired state and the actual state, right? And which is a little bit, different from the traditional approach of consuming APIs just via the CRUDs, right? Via the CRUD operations. All right. So more about reconciliation, right? Kubernetes exposes three methods, three hooks. One of them is add, and the other one is update or delete. And via these three hooks, we try to reconcile the desired state into the actual state. And again, in this particular case, we had a CR, which is known as SPC. That's a storage pool claim. That's, again, the desired state, which should be realized into an actual state. And the actual state here means have a couple of Kubernetes native resources. For example, a couple of Kubernetes deployments, and some additional CRs, which again was managed via their own individual controllers. Okay. Yeah. So what essentially we try to do is we are trying to manage the storage via controllers, and if you're able to have the intent specified in a proper way, we have the job done, right? And so this is what we had felt when we had got into the reconciliation mode. We felt like things were done. We can depend everything on the Kubernetes owns reconciliation system, all the internal mechanisms of Kubernetes, and we should be fine with it until what we found out later. I'll hand over to Ashutosh and let him talk about what happened next.
Thanks, Amit. Yep. Thanks, Amit. OK. As Amit said, it was based on reconciliation of Kubernetes. We defined specs, and we put our intent on the CR, and the controller should converge. But this is what happened next. We got bugs, and we got inconsistent resource count, and it led to data corruption. And the reason was, if you have a CR, the desired state was to have a number of Kubernetes native or custom resources, but then we ended up in inconsistent resource count. So what actually happened was, that when you have a pod running, and even if you have a policy as recreate, if you delete a pod, and if that pod is a custom controller, it is going to accept the events. And any event, let us say create event, it's saying, hey, you got to create k number of resources. It is going to create k plus k number of resources. The same thing, long story short, no two controllers should serve the events. We thought, what should we do? Leader election, but that was too complex to do. We were thinking anything simpler. And what we did was we tried to acquire lock on the custom resources. And this is how we did it. We defined a lock contract that went into the annotation of a CR. And as we know, if you try to update a custom resource, no two guys can update it simultaneously. So this custom resource is having a resource version number, and that's it. So we believe that we don't lock the code, we lock the resource. So for us, the custom resource was a resource that we try to lock it. And if a holder, a controller who is holding the resource dies, we can force acquire the lock. Done. This is some of the future work that we're trying to do with respect to lock. That is global lock, read lock, and write lock on CRs. And obviously, we do have alternatives. One of them is Operator SDK. It's a beautiful project that we use a Litmus operator. It kind of uses leader election to solve the problem. References, and thanks. Questions?
Why would you have multiple controllers running in the first place, not just a single one?
Can you come again?
Why would you have multiple controllers running at the same time?
Exactly. So what happened when we were doing chaos engineering on our product, one of the methods was to delete the pods, right? And as I pointed out, when you delete a pod, even if the policy is recreate, there will be two simultaneous pods, one in terminating state and one in running state. And at that point, you can get events. Yeah.
So it's a momentary effect.
It's just kind of a resiliency test also when you do chaos engineering to the product. Even if you have this undesired state of having two controllers, it will save you from that situation.
Okay. Any other questions? All right.
All right.
Fine.
Thanks.
Thank you. Thanks a lot.